today's video, we'll be going over dimensional analysis, which is kind of, you could think of it as the quintessential skill for all of chemistry. So, what dimensional analysis essentially amounts to is basically a series of unit conversions. So, this is when you start doing things like you're given some amount, given some mass of a product, or if you're doing like a retroactive analysis, some grams of product, and then you use that information to say find the number of liters of one of the reactants. And this is just an example, but it's basically the key skill, because when you know how many products and reactants there are going to be, you can use that information to retroactively find, say, the liters of reactants. If you're using a liquid, if water is one of your limiting reagents, you can use this, some grams of products, to find liters of reactants. So we're going to be doing a bit of a convoluted example today, but we're going to use it to kind of demonstrate all of dimensional analysis. So, for this, what we're going to say is if 25 milligrams of zinc nitrate is contained in a 4.5 liter water sample, what is the nitrate concentration in by ppm? If you guys remember from last video, ppm is parts per million. So we can ask, what are our known values? Well, we know the volume of the solution is 4.50 liters. We know the weight of our solute is 25 milligrams. Using the periodic table, we can find that's a little bit of shorthand I use, but I'm already clear. We can find the molecular weight of the solute, which is a known quantity of 189.4 grams per mole. So, what we can do is to find the parts per million of NO3 minus. This is nitrate. NO3 minus is the nitrate anion. solution, then we can take this and find the number of milliliters of solution. Because as we know, there's 1,000 milliliters per liter. And this will cancel out the liters, so we'll have units of milligrams per milliliter. And then we need this because if we assume the density of this solution to basically just be the density of water, we can say that 1 milliliter of solution per 1 gram of solution. So this, and then we can take this, and we know that we have 1 gram per 1,000 milligrams. So what this ends up doing is we get everything in terms of grams. So what we can do is that we can take this and we can multiply this by 1 mole of the solute, which remember is the zinc nitrate, divided by the 189.4 grams solute, because this grams per mole, this is basically just the inverted molecular weight. So what this does, this cancels out the grams that we have, cancel out the mass. So by doing this, we have the number of moles. Then we can take that, and I'm just going to continue on this next line. So we take that and we multiply that by 2 moles of the nitrate anion per mole, per 1 mole of the solute. Then finally we multiply back out by nitrate's molecular weight to find the grams of nitrate. It's going to be 62 grams per 1 mole. So grams per mole, 62 grams per mole is the molecular weight of nitrate anion. And then this all comes out to a very small amount. We get 0.0000000. Let me just double check that. The amount of zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oops. It's 1 too many zeros. 364 grams of nitrate per gram of solution. My shorthand's kind of weird sometimes. I apologize for that. Here, let me write that out fully. So, now if we go back through and look, we can see that we have milligrams. We have a grams per milligram conversion, but then we divide by grams again. So what this does is that the parts per million is effectively unitless. It's a gram per gram measurement. So when we look through, we can see, okay, liters cancels with liters, milliliters cancels with milliliters. milligrams cancels with grams. Gram cancels with grams. Moles, 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 moles. Grams, grams. You know, everything ultimately cancels out in the end, but we carry the grams through because it's an amount per amount measurement. And so from here, we can tell that, this is per 1 gram of solution. Now, this is not a parts per million answer. What is if we take this number and we multiply the top and bottom by 10 to the 6th. Now, 10 to the 6th is equal to 1 million, right? So, what this effectively does is that this gives us 3.64 grams of the nitrate anion per 1 million grams of solution. And so, parts per million, we have some amount per million. So this means that ultimately we end up having 3.64 ppm, 3.64 parts per million. Now, this one was kind of complicated, but if you could follow along, means you get dimensional analysis pretty well. And you should be on the right track in your chem class, or reviewing, or just learning something new. So thank you for stopping by. As always, if you think I didn't explain something well, or you think I missed something, please let me know. Give me any suggestions you have, and I'll see you next time.